Hello everyone, welcome to Learning Club. Before starting the video, don't forget to subscribe our channel. In this particular video, we are going to discuss mod, which is also termed as model. Examples of calculations of mod and how to calculate mod when we have discrete frequency distribution and how to calculate mode of frequency distribution data. But first we have to define mod. It is defined as the observation that occurs with greatest frequency. In other terms, it can be defined as it is the value that occurs maximum number of times in a sequence of observation. Remember in mind, if we have a data in which no observation is repeated more than once, then there will be no mode of that data. Consider an example. We have values 27, 29, 27, 25, 24, 27, 25, 29. Solution: according to the definition, mode is equal to the most common value in the data. So, as you can see that we have 27 is repeated 3 times. So, the mod of this example is 27. Consider another example. We have data 412, 426, 435, 412, 428, 435, 428. According to the definition, again, mod is equal to the most common value in the data. We have data. You can see that in the data we have 412 and 435 values, means two values which are repeated equal number of time in the data. So the mod or model of this particular example or particular data is 412 and 435. It can be considered a bimodal data. Remember in mind, when we have three values which is repeated equal number of time in data, then there will be three mod of that data. Okay. Now, mod for discrete frequency distribution. The mod is the value of a variable which have maximum frequency. Again, consider an example in which we have values of x 2, 3, 4, 5, 6 and frequency as 8, 15, 23, 20, 14. As mod is equal to maximum frequency of value of variable, you can see that maximum frequency is equal to 23. So the mod of this particular example is 4. Hope you guys are understanding the point what we are discussing, that mod is always the maximum value in the data. If we have discrete frequency distribution, then that value of variable which is having corresponding maximum frequency is the mod of our data. Now, mod for group frequency distribution. The formula for group frequency distribution is equal to L plus Fm minus F1 divided by Fm minus F1 plus Fm minus F2 multiply H. Now, L is equal to lower cross boundary of mod group, Fm denoted for maximum frequency, F1 is equal to frequency of the group preceding the mod group, means the upper value of the upper frequency of the maximum frequency is the F1 and the lower frequency of the maximum frequency is called F2. As you can see that F2 is equal to frequency of the group succeeding the mod group, and H is as usual class interval. Considering an example to clarify the concept, The following table shows the number of men in various age groups with sum of paid employment in a village. The age recorded for each man is the number of completed years lived. Estimate mod. This is the data in which we have in our column 1, 14 to 25 of age, frequency is equal to 12, 20 to 30 of age, frequency is 14, and similarly at the end 71 to 90 years of age, frequency is 1. First we have to calculate class boundaries. You can see that how hope you guys know that how to calculate class boundaries. If you don't know, just comment fall in the comment section. Hope we will discuss the how to calculate class boundary. So you can see that FM is 35. It means we are going to point out this particular group. In this particular group, lower boundary is 40.5 and class interval is 10. You can also see that as we have discussed that F1 is the value preceding to the maximum frequency, means F1 is equal to 21. Similarly, F2 is succeeding, so F2 is equal to 23. Putting the value in the data, in the formula, we have 40.5 plus 35 minus 26 divided by 35 minus 26 plus 35 minus 23 multiply age. When we calculate all these values, we get 44.8, which is the mod of our example. Remember, as we discussed earlier, mod is sometimes called model, but the meaning of both words is same, most common value in the data. Thank you for watching the video. Hopefully we will discuss the last type of calculating center tendency in our next video, which is harmonic mean. In our next video we will end our series of this video, which is how to calculate measure of center tendency. Thank you again.